Start பண்ண madam.
Good morning. Today we are going to see about the combination circuits which will be comes under the digital logic circuits. Before going to start, we will see what is meant by combination circuits. So main classification of a digital logic circuit in which the output is depending upon the present input alone. So what is the thing is that it is not depending upon the previous output. What it is depending upon the present input alone. So whenever coming to the classifications of the combination circuits, will have some of the classifications. In that one we will be having adders, subtractors, multiplexer, demultiplexer, decoders, encoders, code converters and the comparators. So adders and subtractors which are used to add 2 bit of information or more bit of information when it comes into the adders. When I come into the subtractor, it will subtract the binary bits. And when I come into the multiplexer, it is a combination circuit. It should have many input and only one output. Similarly, in the coming to the demultiplexer, it is a type of a combination circuit. It should have one input as well as the many output. So in the case of a decoders, it is one of the another type of combination circuit. It will have n input and 2 power n outputs. When I am coming to the encoder, it is reverse of the decoders. And means coming to the code converters are the combination circuit which will be converting them one type of number system to another type of number system. And when I am coming to the comparator, again it is used to compare the 2 bit of information or more bit of information. Based upon the value, it will be giving the answer. So the very first combination circuit is my adders. Okay. So when I am coming to the adders, we will be having the main 4 types of binary adders. First one is an off adder, full adder, parallel adder as well as the BCD adder. So what is actually an off adder? The off adder is an adder which is used to add 2 bit of information. When I am coming to the full adder, it is a combination circuit which is used to add 3 bit of information. If I am going to add more number of binary numbers, that case you can go for a parallel adder. Okay, so in the 3 cases, it will be concentrating only on the binary numbers. When I am coming to the BCD adder, which is used to add BCD number. So you know the difference between the parallel binary as well as the BCD numbers. Okay, so now we are going to see about the first type of a basic combination circuit, which is your off adder. As I told, the off adder is a device or a combination circuit which is used to add a 2 bit of information. Okay. So in the case of whenever you are learning any combination circuit, you have to learn like this. First symbol, truth table, K-map simplification, logical diagram, like that we have to flow. So when I am coming to the off adder, as I told, the off adder is an adder circuit which is used to add 2 bit of information. When I am coming to the symbol will tell about what are the inputs which will be there and what are the outputs of the particular combination circuit. In the case of off adder, it has 2 inputs. The name is given as an A as well as B, and the 2 outputs, sum as well as a carry. Thus A is and B is a binary number or binary variable which is used to store 1 bit of information. So the output of an adder is one is sum, another one is a carry, where I will be getting in the case of a normal addition. So this is some symbol of the off adder. When I am coming to the truth table, the truth table is a table which will be giving all the possible combinations of input as well as the corresponding output. As in the case of an off adder, we have 2 variables, that is A and B. Okay, and I told that A is a binary variable which is used to store 1 bit of information. So like similarly the B also. When I am coming to the combinations, we will be having 4 different combinations, 0, 0, 0, 1, 1, 0, 1, 1. So now we are going to calculate a sum as well as a carry. So how to calculate the sum means whenever they have to add 2 bits and we have to give the based upon the value, we will be getting the value for the sum. So first of all, when adding 0 and 0, the sum will be 0 and the carry we are not getting any carry, so carry is 0. Similarly, 0 plus 1 we will be getting a sum as 1, carry as 0. And for the third combination, A is 1, B is 0, the sum is 1 and carry is 0. When you are coming to the fourth combination, when I am adding 1 plus 1, it will be like this. So for 3 cases we can able to find the answer easily. But when your fourth combination 1 plus 1, like in the case of decimal 9 plus 1 will be getting 10. No? Similarly, in the case of binary 1 plus 1 you will be getting it as a 1 0, where yes 0 is my sum and this 1 is my carry. So that's why in the case we will be getting sum as 0 and carry as 1. So this is a truth table for your off-adder circuit. So after completing the truth table, we have to go with the K-map simplification. So before that, we have to know how many K-maps you have to go and what is the size of the K-map. Okay. So that is depending upon. First we have to see what is the size of the wave K-map. What is the size means it is a 2 variable or 3 variable or 4 variable. It is depending upon the number of inputs. Here we are having 2 inputs A and B. So we are going for the 2 variable K-map. Okay. And when I am coming to the how many K-maps we have to plot, that is depending upon the number of outputs. Okay. One K-map for sum, another K-map for carry. So you know how to fill this K-map. So again I will be telling how to fill this one. For example, so if you take minterms for this combinations, it will be A bar, B bar, A bar, B, A, B bar and A, B. So we have to know how to fill this combination, that is minterms in the K-map. So in this case, the A bar, B bar, the value of sum is 0. For A bar, B, the value of sum is 1. So A, B bar, the value of a sum is 1. For A, B, the sum is 0. So likewise, we have to fill this one. After filling the K-map, we have to that is, we have to check for the whether the grouping is possible or not. Okay. Now we will see the K-map for a sum. Okay. So after filling this minterms, we have to check whether there is a possibility of doing the grouping. So after filling the minterms, there is no possibility of filling the, that is grouping the ones. So we have to write the term as such by using the corresponding minterms. When you are writing a minterms for this one, it will be A bar B. Similarly for this minterm, it will be A B bar. So you will be getting the equation for sum as A bar B plus A B bar. So now the K-map for sum is over. Now we have to go with the K-map for carry term. So when you are filling the carry for the, that is carry for this, so you will be getting only one minterm is there for the carry. So you will be getting it as an A bar, A as well as B. After simplification, here there is no possibility of doing the grouping. So what you have to write? You have to write the equation as such. So when you are writing the equation for the carry as such, you will be getting it as an AB. So now the K-map simplification for the off-adder is over. Now we have to draw the diagram for this, logical diagram for the sum as well as a carry. So before going to that, we have to check what are the logical gates which can be implemented, which can be used to implement this sum term. So what I am doing is I am writing this expression by simplified form. When I am checking this minterms, it will be A bar B and plus A B bar is an logical equation for the XOR gate. So what I am doing is I am replacing this sum term as A XOR of B. Similarly, in the case of carry term, it will be getting it as an AB, which can be implemented using an AND gate. So when I am coming to the logical diagram for sum, it will be the XOR gate, and for the carry it will be the AND gate. So like this we can explain we can understand the working of your off-adders.